to today's class. Today's class is Rational Inequality Part 4. Rational Inequality Part 4. So, under Rational Inequality, we have treated Part 1, Part 2, Part 3, and we are now in Part 4. So if you have not gone through Part 1, Part 2, Part 3, please try and go through it before coming over to Part 4 so that you understand it better. So, number 4, we have solve x squared minus 3x plus 2 all over x squared minus 9 is greater than or equal to 0. So, that numerator can be factorized. I have done that in quadratic inequality part 1, how to factorize a quadratic expression. I've done that in quadratic inequality part 1. If you go through it, you understand it better. This video is actually a continuation of rational inequality part 3. Alright, which means, to factorize that, what we do is think of two factors that when you multiply, you have this x squared, which is x and x. X times x will give you x squared. The next thing is think of two factors that when you multiply, you have 2. Of course, 2 and 1. 2 and 1. Now, the condition is that the two factors you are using here and using here must be such that when you cross multiply and add, it will give you the middle term. So if you look at it, if you cross multiply this and add, it will not give you the middle term. But if I attach a negative sign here, let's see what will happen. Minus 2 times minus 1 is positive 2. So if we cross multiply this, that is x times minus 1, that's negative 1. Minus 2 times x, that's negative 2x. As you can see, it's giving us the middle term. So once that is achieved, we put these factors in bracket, which means that the numerator can be written as x minus 2, x minus 1. That's for the numerator. Over to the denominator. The denominator is what we call difference of two squares. Difference of two squares. Recall that if you have an expression like this, x squared minus y squared, that is the same thing as one bracket will carry a negative sign and another bracket will carry a positive sign. We call that difference of two squares. If you expand this, you have back this. So difference of two squares. One bracket will carry a negative sign and the other will carry a positive sign. So which means that this is the same thing as saying x squared minus 3 squared. So one bracket will carry a negative sign and another will carry a positive sign. Greater than or equal to 0. So what we do at this point is to equate each bracket to 0 so that we'll have the critical point. So looking at the numerator, if I equate this to 0, I'll have x is equal to 2. If I equate the other one to 0, I will have x is equal to 1. Let's go back to the denominator. If I equate x minus 3 is equal to 0, I'll have x is equal to 3. If I equate x plus 3 to 0, I will have x is equal to minus 3. So these are the points that we'll be considering. 2, 1, 3, and minus 3. Those are the points we shall be considering. So if we have a number line like this, we need a point minus 3. We need a point after minus 3. We need a point 1. Then we need a point 2. And we also need a point 3. Okay. So looking at that number line, all the numbers this way are greater than 3. So that is for x is greater than 3. Okay, greater than or equal to, that's the sign that is there. Greater than or equal to, that's the sign that is there. So all the numbers this way are less than minus 3, which means that this is for x is less than or equal to minus 3. In between is from minus 3 to 1. So we have minus 3 is less than or equal to x is less than or equal to 1. In between is from 1 to 2. So So we have 1 is less than or equal to x is less than or equal to 2. Then in between is from 2 to 3. So we have 2 is less than or equal to x is less than or equal to 3. So we prepare a table like this. Prepare a table for all the factors up and all the factors down. Our first consideration is x is less than or equal to minus 3. Another one is from minus 3 less than or equal to x less than or equal to 1. Another one is 1 is less than or equal to x is less than or equal to 2. And then we'll have 2 is less than or equal to x is less than or equal to 3. And then the last one will be x is greater than or equal to 3. Okay. So for the numerator we have x minus 2. We also have x minus 1. Then for the denominator we have x minus 3. We also have x plus 3. And then combining the two, for the numerator x minus 2, x minus 1, denominator x minus 3, x plus 3. Okay, let's see what happens. X is less than or equal to minus 3. Pick any value in that range. Any number you pick in that range will behave the same way. Any number. So x less than minus 3, we can pick a number like minus 4. Any number in that range. From minus 3 to 1, pick any number in that range. You can pick a number like 0. It is in that range. From 1 to 2, pick any number in that range. I can pick a number like 1.5. It is in that range. From 2 to 3, pick any number in that range. I can pick a number like 2.5. It is in that range. And then from x greater than or equal to 3, you can pick a number like 4. Any number you pick in that range will behave the same way. So let's put in the values and see what happens. If x is minus 4, this will be minus 4 minus 2, which will give us minus 6, a negative value. We are interested with the sign, not necessarily the answer. The sign is what we are interested in. So that will be negative. If x is 0, this is 0 minus 2, that's minus 2, negative. If x is 1.5, we have 1.5 minus 2, that will be minus 0.5, that is a negative value. And if x is 2.5 minus 2, that's 0.5, that's a positive value. If x is 4, this will be 4 minus 2, which is 2, a positive value. We go back to the next one, x minus 1. Now, when x is minus 4, this will be minus 4 minus 1, which is minus 5, a negative value. When x is 0, a negative value. When x is 1.5 minus 1, that is 0.5, a positive value. When x is 2.5, a positive value. When x is 4, a positive value. Over to the next one. When x is minus 4 minus 3, that's minus 7, a negative value. If x is 0, this will be 0 minus 3, that's minus 3, a negative value. When x is 1.5 minus 3, that's negative 1.5, which is a negative value. And so if x is 2.5 minus 3, that will be a negative value. And if x is 4 minus 3, that is a positive value. The next one, if x is minus 4 plus 3, that is a negative 1, a negative value. If x is 0 plus 3, a positive value. If x is 1.5 plus 3, a positive value. If x is 2.5 plus 3, a positive value. And if x is 4 plus 3 is 7, a see what happens here. This bracket times this bracket simply means this times this, which is positive. That's negative times negative, positive. And then for the denominator, this times this simply means negative times negative, which is positive. So what we are having is positive divided by positive is positive. For this other one, this bracket times this bracket means negative times negative, that's positive for the numerator. Then for the denominator, negative times positive, that's negative. So we are having numerator positive divided by negative, that's negative. Over to this one, negative divided by positive, that's negative for the numerator. Then the denominator, negative divided by positive, that's negative. So we are having negative divided by negative. This is negative times positive, that's negative. So we are having negative divided by negative, positive. Positive times positive, that's for the numerator, positive. Then the denominator, negative times positive, that is negative. So we are now having positive divided by negative, that's negative. Positive times positive for the numerator, positive. Positive times positive for the denominator, positive. So positive divided by positive is positive. So at this point, what we do is go to the equation and check the sign. Check the sign in the equation. The sign in the equation is greater than or equal to. So any number greater than or equal to 0 must be positive. Any number greater than or equal to 0 must be positive. So we check for the positive ones. We have it here, we have it here, we have it here. So it therefore means that the solution will now be all those ones that are positive. 1, 2, 3. So the solution is x is less than or equal to minus 3, or another positive is here. 1 is less than or equal to x is less than or equal to 2, or another positive is here. X is greater than or equal to 3. Those are the answers. And now one may be wondering, how possible is it that this is the answer, or this is the answer, or this is the answer? What that simply means is that for any value of x that you pick in either of them, it will satisfy this inequality. What that means is it is not possible for you to pick a value in either of this range, put it here, and this statement will be false. It is not possible. It is not possible. For example, x greater than or equal to 3. If you pick a number like 10, put it here. 10 minus 2. 10 minus 2, that is 8. 10 minus 1, that is 9. So as you can see, 8 times 9, that is a positive answer. And if you do the same thing in the denominator, 10 minus this, that is 7. 10 plus 3, that is 18. 7 times 18, still giving you a positive answer. So positive divided by positive must give you positive, which means greater than 0, because any number greater than 0 is positive. If you also consider this range, any of them you consider, the statement must be true. So that's the meaning of the answers that we are having there. So with that, we have come to the end of rational inequality part 4. Do well to subscribe, like, and share. Thanks for watching. Bye.